So subtraction of fractions is a whole lot like addition of fractions, only we don't use as many units for that. We use the idea of comparison, how many more or how much bigger one area is than the other. So, for example, if I wanted to subtract 1/2 minus 1/3, I'm going to draw just two units, and like for addition, I'm going to model both 1/2 and 1/3. So I'll draw 3 by 2 units. Here's one, and here's another. And in the first one, I'm going to model 1/2, and the second one, 1/3. Now, I will, again, like I've been doing, use a different color for each one. There's 1/2. And then for 1/3, here we go, use this. Now, I'm going to, if I were actually using the rods, I would place the rod that models the 1/3 directly on top of the rod modeling the 1/2. So it would go right here. The question I'm asking is, 1/2 occupies how much more space than the 1/3? And you notice that there's 1 square centimeter, one of those small squares, that is left here, the 1/2 that was not covered by the 1/3. And if you then will think of breaking this up into small units, you can see that it's 1/6 of our original unit that was not covered by the 1/3. So the 1/2 is 1/6 bigger than the 1/3. So you can do this with color. You can also do it with X's. So that would be to put an X here for each of these units that are here, and there was one of these units left over. So how many squares for 1/2 were not covered over? That would be 1. How many squares fill the unit? 6, and that's again showing that 1/6 of the 1/2 is left over. And to show how this works with the traditional algorithm, 1/2 we can see is the same as 3/6. 1/3 we can see is the same as 2/6. And when we subtract the numerators, 3 minus 2, and get 1, and we keep the denominator. Again, we're dealing with, we can break both of these into 6. We're dealing with 6 everywhere. 3/6 take away 2/6, or 3/6 is 1/6 bigger than 2/6.